Hi everyone. So in this video, I'll discuss about the stack data structure. I'll give a brief introduction about the stack data structure using some real world examples, and I'll also discuss about where this stack data structure is used in real life. So a stack is LIFO kind of data structure. What I mean by LIFO is last in first out kind of data structure. So the element which gets pushed at the last will be the first one to be popped out. So let's say we have a stack like this, and if we push some elements in this stack, so the element which gets pushed at the last will be the first element to be removed. So in this case, 3 will be the first element to be removed. We can also say that a stack is a first in, last out kind of data structure as well, because the element which gets pushed first will be the last one to get removed. In this case, one was the first element to be pushed inside the stack, so it will be the last element to be removed. Now, some real world examples of stacks could be a stack of plates. So let's say we have a stack of plates. So, so the plate at the top will be the first one to be removed, and the plate at the bottom will be the last one to be removed. So that's why stack is called as last in first out or first in last out kind of data structure. Some other examples could be a stack of cards. Now coming to some places where this stack data structure is used is uh, this stack is used in the undo redo features in various applications. So whenever you do undo, so the operation which was performed last will be the first one to be reversed. So that's how stack is used in undo redo features. Similarly, in forward and backward features in web browser, stack data structure is used. Stack is also used in function calls, and pertaining to each function call, we have something called as a stack frame. So let's say we have a function A. So for function A, we will have one stack frame which will contain all the variables which are local to this function A. Then let's say A calls function B. Then we'll have a stack frame pertaining to this function B. This pertaining to function B will contain the local variables of function B. Then let's say B calls C. Then we'll have another stack frame for this function C. Now let's say this function C gets executed. So this C, uh, the stack frame for the function C will be popped out from this stack, and then the program counter contains the address of the function B. It executes it. Then B also gets popped out. Similarly, A also gets popped out, and the function A will be the last one to get returned. So this was a brief overview of how this stack data structure is used in function calls and some other places like undo, redo, and forward and backward features in a web browser. Now, coming to the stack operations, like what are the basic operations which are there in this data structure. So the first one is push. So what push will do is it will simply push an element into the stack. Let's say we have a stack called s. Then s dot push 3 will push an element 3 into the stack. And if we do s dot push 2, then our stack will look something like this. Then the second operation which we have is pop. Pop will simply pop an element out of the stack. So if we do s dot pop once, then 2 will be popped out and our stack will look something like this. If we do s dot pop again, then 3 will also get popped out and our stack will become empty. Then we have top. So what s dot top will do is it will simply return the element at the top of the stack. In this case, we don't have any element, but let's say we again do s dot push 4, then we'll have 4 at the top of the stack, and s dot top will return 4 in this case. Then we have is empty. So is empty simply returns if the stack is empty or not. In this case, we don't have our stack is not empty, so is empty will be false. It returns a boolean value. But let's say we pop out 4 as well, then in that case the is empty function will be true, will return true. Then the last one is size. So s dot size simply returns the size of the stack. So currently our stack doesn't have any elements, so s dot size will be 0. But let's say we have an element 5 also, then s dot size will return 1. Now I'll briefly give a demonstration of this stack in C++ STL library. So to use this stack, we'll have to import this header file stack, and the syntax for using this stack in STL is something like this: stack int. Let's say we name our stack st. Now we push few elements. The first operation which we discussed was push. So s dot push 4. Let's push few elements. Push 5. Okay, let's execute this. Now let's print the element at the top. So since 102 was pushed at the last, it is the element at the top. Now let's pop 102 and again print the element at the top. Now 5 should be the element at the top. Let's first build it and then execute it. Yeah, so 102 was the element before popping the element at the top, and now 5 is the element at the top. Now the other operation which we discussed about was is empty. So let's build it. So 0 means false, so that means the stack is not empty yet. Now let's also print the size of the stack. Let's build it. So the size of the stack is 2. We pushed 3 elements, we popped 1 out, so the size now is 2. Now let's once clear the stack. And then print the size of the stack, and also we'll print if st is empty. Let's clear all this up, build it. Yeah, so the size is 0 since we popped all the elements out until the stack becomes empty, and after that st.empty is 1, which means it's true. So that's all. Hope you like it.